Hey everyone, this is Rick Husey. Welcome to Broadband Deployment News. Today's topic is millimeter wave. Is it already dead before it got off the ground? Pretty much. I don't know. We'll see. Hang on and we'll talk about it. Thanks for joining me for Broadband Deployment News. So when 5G was first talked about, there was a lot of hype about it, a whole lot of hype about it. Everybody's talking about how this was going to be something that was going to be competing with all of the wireline competitors, and cable modems especially was talked about. Could this be something that would be competing directly with the cable industry? Because we're talking about wireless service here at very, very fast speeds, like gig speed wireless, very convenient, no wires in the home, this kind of thing. I've been saying for years now that I didn't think that was the case because of the millimeter wave band being something that is not really conducive to a lot of areas. But of course, we're seeing a lot of emphasis on 5G now, but that's not millimeter wave. So I saw a couple of stories here that was making me think it might be a good time to talk about this again. First was this blog post from Pots and Pans that says the death of millimeter wave cellular, ? And this is talking about cellular service. So he makes some good points here as far as cellular goes. So he says Apple recently announced that it is not building millimeter wave spectrum antennas into the next generation SE iPhone. Interestingly, this is a phone sold by Verizon, which spent a year advertising on TV and showing us speed tests on cell phones that were receiving gigabit speeds. So Verizon was one that was pushing millimeter wave because they had that spectrum, and they were going to be, making hay out of the fact that it's so fast. And again, this was kind of in the early stages of 5G, and talking about how fast this was and relative to everything else. And is this something that people really needed on their phones? That they need these kinds of speeds on their phones, and is it useful for that? And but there's also the fixed wireless aspect of 5G. So Verizon and AT&T both deployed some millimeter wave hotspots in downtown areas of major cities at the height of the 5G marketing craze. Especially Verizon, they were really focusing on several urban areas and putting 5G out there with millimeter wave. And the reason they're doing urban is because millimeter wave it's very fast, but it does not propagate well. There's very high attenuation from anything, trees, rain, humidity, and as he mentions here, even your body if you're using this for mobile. So the speeds can be blazingly fast, but millimeter wave signal only carries perhaps 1,000 feet from a hotspot. Actually goes further than that, but and he says that's with zero objects in the path. Millimeter wave spectrum penetrates nothing, and the technology is so finicky that if you were receiving a signal and turned away from the transmitter, your body would cut off the transmission. Frequency is not well suited for busy urban streets, can't reach around corners, barely goes through glass, and is blocked by anything moving its path. So you could see where for mobile service that might be a problem, where if you're trying to use your phone, and it's like you might have to turn a certain way to be able to get the signal. And they're trying to do some things to mitigate that. They have some beam forming and some, these signals, they don't go through anything, but they do bounce off of stuff. So if you arrange your antennas in a certain way, you can actually get a more rounded coverage in an area. So you get the strong signals, the beam forming, but you can also get reflections that can provide pretty good service in these areas. But again, for mobile, I'm not sure if it's needed or how well that works in this case. So pushing the millimeter wave fast 5G story was a big part of the early 5G strategy for the cellular carriers, and that's true. You heard about that all the time. Everybody's talking about, hey, 5G, that's the next big thing. We're talking about gigabit speeds. Everybody was excited. Others were worried. Again, in the cable industry, they were worried about this, and what would that mean? The cellular carriers stirred up everybody in D.C., and we had Congress, the White House, and the FCC all issuing dire warnings about falling behind with 5G. And yeah, you heard that about, hey, we're going to be behind all these other countries that are getting 5G out. The FCC worked hard to get out new spectrum, but not, it wasn't so much about millimeter spectrum at that point. It was about what can we do in the mid-band spectrum, be able to get out much faster spectrum that we have now, let's say for 4G, that we can use for 5G. So there was the CBRS spectrum auction, there was the C-band spectrum, there's 2.5 gigahertz spectrum right now that's being auctioned off, and that's already being leased to people like T-Mobile, but there's the FCC is auctioning that as well. So It says, he finishes up here, he says, it's not surprising that Apple is dropping the spectrum from its phones. It costs chip space and power for everybody, or for every additional spectrum that is supported by a cell phone. So if you're going to support this spectrum that nobody's using, there's resources involved in that. Cell manufacturers care more about long battery life than they do about a technology that never made it out of the downtowns of a few major cities. And that is part of the issue, is that with this spectrum not propagating very far, again, you need line of sight, you need lots of cells, small cells, line of sight. So it can work in an urban area, but if you have these long distances and any kind of obstructions in between, trees, whatever, it's not like regular cell service where you can put a tower way up high and then send that signal out far, because it doesn't go that far. So I think we always knew this would be something that would be more in a densely populated area than, let's say, in rural areas. So that's one reason I didn't see it much of a threat, because let's just even talk on the fixed wireless side. Actually, I'll talk about that here in a minute. So let me get to this other story. So the other story that I saw, which was telling me that it's not necessarily dead, certainly not for fixed wireless as a solution here, because here it says Starry seeks to test mmWave gear in nearly 24 cities. So Starry is, they're already offering this service, and they're seeking to test it in a bunch more cities. Fixed wireless broadband provider Starry potentially shed some light on its expansion roadmap, requesting permission from the FCC to conduct tests of prototype mmWave equipment in 22 cities. These include more than a dozen where it does not currently provide service today, so they're looking at expanding with mmWave. 15 prototype base stations and 250 prototype end-user devices running on spectrum between 37 gigahertz and 38.6 gigahertz at each location. So that's the big difference there. So mmWave, 30 to 40 gigahertz, in that range. If you're looking at mid-band spectrum, the kind that T-Mobile is deploying, most of that's 2.5 gigahertz, and you've got CBRS and C-band, which is in the 3.5 to 4 point something gigahertz range, I believe. So you can see this is like 10 times that. So that's why it's about 10 times faster in a lot of cases than some of these other 5G offerings. The company previously stated it is pursuing an expansion roadmap that will see it cover more than 40 million households across the U.S., reached a total of 5.3 million homes as of the end of Q4 2021. So they're looking at expanding to more than 40 million households with this really fast mmWave. So that will be interesting to see if they're successful with that. Now, at this point, all they're doing is asking the FCC for the ability to test this in these cities. So this is not where they're actually ready to deploy. They want to test it. Starry's looking to get a better sense of how the combination of electronic steering, multi-user MIMO, and point-to-point technologies will perform in dense urban settings with more physical obstacles. So again, you can set up these antennas in such a way where you can actually make use of some of the fact that the signals bounce off of things as opposed to passing through them. Will bounce off of buildings. A lot of it reflects off of glass, that kind of thing. So experimentation with this technology is necessary to determine how to maintain quality links over meaningful distances and across different urban topographies and rain zones. And rain is another thing. So it's kind of like if you've got a Dish Network or DirecTV and you're watching TV and it starts to rain, south of you, and then suddenly it's like you get this rain fade situation where the signal will go out or it gets degraded. We have the same issue with 5G. It does not handle rain well because it's just one more obstruction. Even humidity in the air can degrade the signal. In a note to investors earlier this week, New Street Research's Jonathan Chaplin argued the new kind of fixed wireless service Starry provides poses more of a threat to cable operators than the kind offered by mobile juggernauts T-Mobile and Verizon. That's because it makes use of a dedicated mmWave spectrum that circumvents both the supply and demand constraints faced by mobile operators who are using the same mid-band and mmWave airwaves to serve both their fixed wireless and fully wireless customers. Meanwhile, operators using Starry's model can deliver a fiber-like experience over mmWave spectrum, Chaplin wrote. And I really disagree with that, because I think the real threat is the kind of 5G that Verizon and T-Mobile and AT&T, for the most part, are delivering right now. So Verizon started in the mmWave spectrum because that's all they had. But they participated heavily in the C-band auction. They've got C-band spectrum now. They've been rolling that out. Just recently, the other day I mentioned a story where I think they signed up over 200,000 broadband subscribers in the last quarter, And most of those were fixed wireless. It didn't say necessarily that what spectrum it was, but it was most likely their C-band spectrum customers. So they're way exceeding their fiber deployments as far as getting new customers on with this 5G. And it's because it can be deployed very quickly. You get your tower up and there's no fiber to run. You just get the CPE at the customer site and you're off to the races. So I see that as a bigger challenge for cable operators. As long as the cable operator is providing good service, somebody's going to be less likely to switch. But if a wireless operator can come in and provide good service and it's not that much of a hassle to switch, and you're getting service over 100 meg, let's say you're getting well over 100 megabits per second, and the cable operator, let's say, is not offering that much over that, they can offer higher speeds but not much over that, then there is certainly, I think, a threat there. But the thing with millimeter wave is if it's going to be focused on really highly dense areas, then you tend to already have a lot of competition in there. So you've got your cable operator, and that's where the cable operators are increasing the capacity of their plants the highest, because they are competing with fiber operators who are also in these urban areas. So you've got fiber out there, you've got cable out there, you might have one or two other kinds of competitors out there, maybe an independent fiber operator. So you've got all of this competition in these areas, specifically because you have a lot of potential customers. So because of that, I don't see how, 5G will just be another competitor. So I don't see it as being a threat, more of a threat there. I see the issue as being where 5G can really get broad reach in rural areas, areas where maybe the cable service is not quite as fast. I see that as being the issue for the cable operators. The company noted in its application with the FCC that it's working to boost its bandwidth capabilities even further with the development of new dual band equipment that will combine unlicensed 6 gigahertz airwaves with licensed millimeter wave spectrum. It currently offers download speeds ranging from 50 megabits per second to 1 gigabit per second, with availability depending on the location. So obviously that's a huge range there. So I think with the 50 megabits per second, they're talking about their traditional fixed wireless on low band spectrum versus doing 5G with millimeter wave and getting up to a gig with that millimeter wave. These additional channels will be combined for throughput with the millimeter wave channel, and therefore in many cases will double the overall throughput. So I think they may be talking about higher than maybe 2 gigs maybe they're talking about like 2 gigs with that. So and the other thing with millimeter wave is it talks about Wi-Fi 6 here and 6 gigahertz, and that's what they're talking about. I think that's what they're talking about. New dual band equipment that will combine unlicensed 6 gigahertz airwaves. So maybe it's not Wi-Fi, but they're talking about doing fixed wireless. Maybe it is like Wi-Fi, but 6 gigahertz. So you got Wi-Fi 6. Wi-Fi 6 doesn't have to use the 6 gigahertz band, because the 6 is really the version of Wi-Fi. It's not the spectrum. But Wi-Fi 6 is starting to support 6 gigahertz. So they may be talking about somehow combining these two technologies and getting even faster. And it's interesting because one of the use cases for 5G would be a private 5G network with millimeter wave. Because again, if you're doing a private network, it's all about getting lots of speed and low latency. Maybe it could be a stadium. I think that's an opportunity, would be like 5G in a stadium, where you can have microcells up, and again, you can be bouncing off of stadium walls and get good coverage. Or it could be in a large warehouse, maybe where you want to do a private 5G network. But then again, Wi-Fi 6 is another option for these things. So I don't know how that's going to play out as far as whether 5G or Wi-Fi 6 are going to be the way that people go with these private networks. One of the things that's going to be driving this is a lot of IoT kinds of devices. If you've got lots of devices that need, again, lots of information to be transferring, and low, you don't want a lot of contention. Both of these technologies, both 5G and Wi-Fi 6, can handle more congestion on the network. So anyway, I don't think millimeter wave is dead. I think there are specific use cases for it. One of which would be highly dense areas, but again, in the highly dense areas, there's more competition. So I think it's going to be just another competitor offering broadband service. So that's just, if you're a broadband provider, it just means make sure that you're offering good quality service, which means a fast connection, low latency, and good customer service, right? Good technical support, those kinds of things, to make sure that your customers are happy. Because if they're happy, then they're less likely to say, hey, I think I'll leave for this other service. The other thing is to provide value add over that connection. So If you're just providing a connection, then that's all that's holding your customer to you. But if you're providing services over that, then there's more stickiness there. So if you're providing voice service over that connection, if you're providing IPTV over that connection, then that provides some stickiness. So that's the other thing. So make sure that you're offering good service, make sure that you're offering value, make sure you keep your prices in line, and you're going to have to. If you've got competitors in your area, you're going to have to make sure that you're matching them. So anyway, if you need help with any of these things, including providing services over your broadband connection, make sure you give us a call. We've got a hosted cloud-based VoIP solution. We've got a hosted IPTV solution that requires very little equipment in your network. And there's no set-top box required. We handle all the programming. You don't need to deal with that. So very easy to get in the video business if you're in it, and if you're not in it. And if you are in it and you're doing, let's say, QAM-based video over DOCSIS network, then you can reclaim all of that spectrum by getting into our IPTV product, and then you can reclaim that spectrum and put it towards your broadband service, so you can increase speeds and capacity for your customers just by switching over to our video service. So something to keep in mind. Make sure you give us a call, or you see our contact information here for email and our website. So thanks for joining me today. Give me a like if you like this video, and subscribe if you're not. Click the little bell. You'll be notified when I'm live. Thanks a lot. Talk to you next time. Bye-bye.